Now our Superpave method requires that the air void content should be 4%. So whatsoever the calculation we have, on this calculation, for example, my specification says 4% and my trial value which I have made at the rate of n design may be more or may be less. May be less than 4%. So our target is to convert all those volumetric properties to the 4%. So this is our fundamental aim of this discussion, which we are going to carry on over here in our lecture. So how will we do this one? Let me tell you. First point, requirement 4% for air voids. Calculated value at the rate of n design. How will we do? We will calculate this difference delta VA. 4 minus VA. This is very fundamental equation. I don't know, this VA can be more or this VA can be less. We will adjust it. This is my first point. Second point, you know, if this VA need to bring at the 4%, all the properties will change. So here we will estimate what we will estimate PB change for VA is equal to 4%. What do you mean by this? Here means this is our bitumen percentage. When we have to change our air void to the 4%, its value will also change. How much its value will change? It is given by this formula. Delta PB is equal to minus 0.4 into delta VA. This is the equation. It means what will be our final binder content? We can write on PB final is equal to PB initial, which we have used at the trial, minus 0.4 delta VA 4 minus VA. As you see this equation, let us suppose I am going to give this number equation number 1 and I am going to give number 2 this equation. Here I would like to tell you, okay, when this is my requirement, it means there is some change. If the air void is need to be changed, so it means our binder content will also need to be changed. Every property will change. Similarly, my third point, estimate VMA change for VA is equal to 4%. It's very interesting. Okay, what will be the VMA change? Let me tell you over here. It will become delta VMA. How much value will change? This delta VMA can be written as 0.2 into delta VA. If condition VA is greater than 4%, and this delta VMA is equal to negative of 0.1 into delta VA if my air void is less than 4%. Try to understand one thing. This is my target. When I have made the blend, when I have made the specimen from this blend, there air void may not be 4%, it can be 4.5, it can be 3.7. If it is 4.5, we will use this condition. This condition. Let me write down condition number A. If it is a 3.4, it is less than 4%. Let me write down condition number B, then we will write down this condition B. Due to this change, if I will take into account this change, what will be our final VMA? VMA final would be equal to VMA, which we have calculated at the initial stage, plus this delta V, MA. Whatever the values computed from A and B, if we will put this value in this equation, whatever your value is coming, it would be coming our VMA final. This word which I have written over here, VMA final, it is my final requirement. This VMA initial, which I have taken the initial value when the sample is taken from the gyratory compaction, and this change of value is put in order to get this value. But here I would like to tell you one thing. You know, when this VMA is changed, when our air void content requirement is 4%, then it is natural that VFA will also be affected. So here I would like to give you this result of this VFA over here before I run all this one. Means VFA final, wide fields with asphalt final, would be equal to VMA final minus 4% air void, which we have our requirement, into VMA final multiplied by 100. That's it. So it means if my VMA are changed and my air void is constant, I have to convert into 4%. Whatever this value coming, it will be VFA final. Clear it? Now, after doing all this calculation about this VMA, and other very important property which is related to the level of compaction would be explained over here, and it will show that all the values are nearly getting some type of the change. Okay, like my next quantity percentage GMM at the rate of N initial for VA is equal to 4%. We have to write down this equation. GMM at the rate of N initial final would be equal to percentage GMM at the rate of N initial minus delta VA. This is the value. Similarly, other formula, percentage of GMM at the rate of N design for VA is equal to 4%. It will also be written like this one. percentage GMM at the rate of N design final would be equal to at the rate of N design initial minus delta VK. Okay, this is the value which we have calculated in our initial stage. At the trial stage, you can see that, just for your understanding. And this is the value coming after the adjustment. So these are our 5 very important properties. With these 5 properties, I will try to explain each blend that how much value is being affected when we have to go for our assumption that air void should be kept at 4%. Thank you for seeing this.